Okay, and welcome back. And today we are going to finish up chapter 7, and it's all about Bayes' theorem. Bayes' theorem is a way of calculating conditional probability in a general case. We're going to talk about a specific case, a special case, but then we're going to generalize it. But it's based on when you have a situation where you have an event that basically what's the word I'm looking for? It overlaps several different events. So what you're doing is you're taking the sample space and you're partitioning the sample space into different events. Okay, where if you add up all of those events, it adds up to the sample space. And then you've got this one event that you're interested in, but that event overlaps many of these other events. And so Bayes' theorem is a way of calculating conditional probability by considering all of those partitions. Okay, so this is the idea. And so using a tree diagram is going to help understand, because we've seen this before. So in this is a simple case where I have two steps here. So I have F and not F. So we're partitioning the sample space into two pieces, either your F or not F. And then there's this other event that E, let's say a circle that straddles both of these events. So if you picture in fact, I'm going to do it this way so you can see a very simple example. So let's do this. So let's say we have this, okay? And so here's our sample space, and I split it, right? So here is F, and here is not F. Okay, and then let's say I've got E, and E does something like this. Okay, so E covers both F and not F. So in this case here, think about it. So what I'm doing is, if I want the probability of let's say the probability of E, let's say, what if I want the probability of E? Okay, well, if I have this tree diagram, I have the probability of F and the probability of not F. That's going to be either side. And then there's the probability of E given F, right? And then I have the probability of not E given F. And then I have the probability of E given not F. And the probability of not E given not F. So that's basically these four regions, 1, 2, 3, 4. So it makes sense that if I add up all these probabilities, it adds up to 1. Okay, and if I add up these two probabilities, right, it adds up to 1. Right, so I'm partitioning the data, or excuse me, not the data, the sample space here. Okay, so this is the probability of F and E, right? So by definition of conditional probability, we've got all of these, right? So the condition of these two, it gives is this region, and then this region, and then this region, and this region. Okay, and so this is the idea of using this tree diagram to kind of set up Bayes' theorem. Okay, so far so good? Good. So all I'm doing is using the tree diagram, what we all know, to set up this idea that, hey, these three probabilities represents each one of these four regions. And then we're going to add these up, and they add up to the sample space. Okay. So in this case here, if I wanted the probability of F, given that E has occurred, right? So now I want the probability of F, right? I want the probability of F if I know that E has occurred. But E overlaps both of these, right? Well, it's going to be the probability of the condition part here divided by both of these. So it's going to be the probability of F given, or times the probability of E given F, okay, which is what? This one right here. Probability of F times the probability of E given F. And that's going to be divided by what? The probability of this probability plus this probability. Well, what is this probability? Oh, hold on. It's going to be the same as this, right? Plus the other piece, the probability of not F given E times the probability of E given not F. Okay, well, which one's that one? That's going to be this one. Oh, this one right here. Because I want the probability of E given F. Well, then I need the probability of the conditional probability over here, right? Which is going to be the probability of F times the probability of E given F. And then I want the probability of F, not F, times the probability of E plus of not F. These two together will give me the bottom, right? And then I'm going to take this and it's going to go on the numerator. Okay, so this is Bayes' theorem for this special case. Now this is what? This is the probability of F and E, right? This, what does this add up to? This is the total probability of F, because this is the probability of F and E plus the probability of not F and E. So what is this the probability of? Oh, did I say F? No, I meant E. This is the probability of E, because this is the probability of F and E, and this is the probability of not F and E. If I add those two probabilities together, well, what do I get? The probability of F and E is this right here, and the probability of not F and E is this one. If I add those together, I get E, right? So you can see that Bayes' theorem is the conditional probability of F and E divided by E. It's just using another formula because of the situation. We get something like this, okay? So now let's look at this one. So now here's the way it works. So we've got the probability of F is 0.1. We get the probability of not F is 0.9. And then we've got the probability of E given F is 0.3. And so this is 0.7, this is 0.2, and this is 0.8. Okay, so now what we're going to do is we know by going down the branches, we've got the multiplication rule. So we've got all of these probabilities by just multiplying down. So this is going to be 0.03. This is going to be 0.07. This one's going to be 0.18, right? And this one's going to be 0.72. Okay, and so if we add those, we should get 1, right? So this gets 0.1. These will add up to 0.1. This will add up to 0.18. So that'll be 0.28. And this is going to be 0.72, which will add up to 1. So that works. Okay. So now, by using Bayes' theorem, okay, we can find the probability of F by taking the probability of F times this, okay, which is what? 0.03. And then we're going to take this plus this, which is 0.18. So 0.18 plus 0.03 is 0.21. So 0.21, so it's going to be 0.03 divided by 0.21. And that's going to give us our conditional probability. Okay. And here's another one. We can do the same thing. Now, in the general case, notice what we do. We do the same thing in the general case where we're just going to have the probabilities of F1 in E, F2 in E, Fi in E, to all the way to F sub n in E. And it's all going to be based on just using the definition of conditional probability. And we're going to basically, all of these add up to the sample space. So we're partitioning the sample space into regions, where all of these regions are going to add up to the total sample space. And so this is what we have. Okay. So in this case here, we have E, and E spans all of these partitions. So if I want the probability of F, okay, I want the probability of F given E has occurred. Well, Bayes' theorem says I'm going to have to figure out, okay, or excuse me, if I want the probability of F2. Let's say I want the probability of F2 occurring. Well, in order to calculate, given that E has occurred, but I don't know. I know E's occurred, right? But so how do I figure out the probability if I know E's occurred and E overlaps all of these different events, and I want to know what the probability that F has occurred given that I know E's occurred. Well, in this case, Bayes' theorem is what we want to use, because what we're going to do is we're going to take the total probability of E by saying I want the probability of E given F1 plus the probability of E given F2, the probability of E given yada yada yada, all the way to the probability of E given F sub n. So that's going to give me my denominator. So I'm going to add all those probabilities up, and that'll give me the probability of E. And then I'm going to divide by the conditional probability of the piece that I want, which is the probability of F2 given E. Okay? Or excuse me, the probability of E given F2 has occurred. Okay? And so the probability of F, right? Probability of F and E, we're going to use the probability of F times the probability of E given F has occurred. Okay? So this is the special case. So now if we go here, now what we're going to do is we're going to say what's the probability of F2 given E. So we're going to use conditional probability of this one. So it's going to be this piece here, which is going to be the probability of F2 times the probability of E given F2. And then we're going to take all these other pieces and we're going to add them together, and that's going to be the denominator. And so this gives us the general formula for Bayes' theorem. If we want the probability of F sub I, given that E has occurred, we're going to have to find the probability of F sub I and E, which is given by this conditional probability. And then we're going to divide it by the total probability of E, which is given by the formula of just summing up all of the individual probabilities of F and E by each piece of F. Okay, so here's the way the tree diagram works, okay? So you start a tree diagram with branches representing each of the n pieces, the partitions, right? F1 through Fn. You're going to label each branch with its corresponding probability. And then from each end of the first branch, of these first level of branches, you're going to draw a branch for the event E, okay? And you're going to label that branch with the probability of reaching it, okay, which is going to be the conditional probability. Now, you now have n different pathways that will result in event E. Okay? So next to each path, you're going to put the probability for that particular branch. The product of the probabilities on the branch, right? So you're going to multiply down each branch, and that's going to give you the probability, okay, the conditional probability of f sub I. And E, right? So it's going to give you these probabilities, these intersections, right? Okay. And then what you're going to do is the probability of f sub I z is found by dividing the probability of the branch, the one branch that you're interested in, divided by the sum of the probabilities of the branches producing event E. Okay? Producing event E. So now in this example, if I want the probability of, well, let's see. I want the probability of a randomly selected person being new given that the part is defective. So I want the probability that the operator is new given that the item produced was defective. So the way Bayes' theorem works is we're going to figure out all the probabilities of each branch, right? So this is going to be 0.6 times 0.1. This is going to be 0.6 times 0.99. This one's going to be 0.3 times 0.025. This one's going to be 0.2 times 0.097 or 0.975. This is going to be 0.1 times 0.6, and this is going to be 0.1 times 0.94. And that's going to give us all of these. But now, if I want the probability that the randomly selected person is new, given that the part was defective, if I selected a randomly selected part and I want, hey, what's the probability that the person who made this item is new, given that this piece is defective? So what I would do is, well, I want the probability of, think about the conditional probability. I want the probability of being both new and defective. So that's going to be this probability right here, divided by the probability of being defective. Well, what's the probability of being defective? Well, it's going to be this probability plus this probability plus this probability. Well, how do I get those probabilities? Well, I'm going to go down this branch. So it's going to be this one plus this branch plus this branch. So this is going to be the total probability of being defective. If I add these up, and then I'm going to divide by what? I'm going to divide by this this is going to be my denominator. So what I'm going to do is I'm going to take this probability, which I'm interested in, divided by the total probability of all three of these, and that's going to be the answer. Okay, so now here's another one. So in this case here, I have the supplier, and I have fraction of total supplied, and the probability of defect. So now here's my supplier, right? So each of the supplier, this is the fraction of the total supplied. So this is the fraction, so each supplier makes up the total. So now, and this is the probability of being defective, given for each one of these, right? So this is the probability of coming from this supplier. So these are the probabilities that the items come from these suppliers, and this is the probability of being defective given that it came from this supplier or being defective. Okay, so the probability of being defective and from the supplier is going to be this times this, right? So now I can say, okay, what's the probability that the items came from supplier 4, given that I know that the part is defective? Well, what's the probability of being defective? Okay, well, in this case here, I'm going to use Bayes' theorem because I need to find out, hey, what's the total probability of being defective? That's going to be all of these, right? So I'm going to take this probability. So I'm going to multiply across this, cross this, cross this, cross this, cross this, cross this, right? And so those I'm going to add up, and that's going to give me the total probability of being defective. And then I'm going to take this probability, because this is the probability of being supplier 4 and being defective. And so this is going to go in the numerator. The rest of those are going to go in the denominator, and then I'm going to divide. And that's the end. Okay, so again, let me know if you want me to go through these in class, and we will. And we'll go ahead and calculate these probabilities, but practice these, please. Bayes' theorem is complicated, so go through and do the examples in the textbook. Okay, there are your turns. There are other examples in the textbook. Go through those. Write down your questions. Write down what you don't understand. Write down where you get stuck, or if you get stuck, come to class and tell me, hey, I was working on this problem, I got stuck, here's where I got. And we'll work through it together, and we'll make sure that you understand this stuff. So again, until next time, I'll see you later. So this wraps up Chapter 7. Gosh, I'll talk to you later, and have a great night. Bye-bye.